Hey everybody, how's it going? Today I want to make a video outlining the concepts of arrays. Again, we're going to go into kind of the basic syntax and what's important to understand about arrays. And just as a reminder, we're going to be switching it up a little bit. We're focusing a little bit more on the free response portion, knowing that on the AP exam they're going to be asking us probably 2 free response questions, and I'm going to guess that one of those is going to have to do with arrays. So it's important to understand what type of problems you may see on an AP exam dealing with arrays. So for the first thing that we want to go over is just in general, arrays are known as a data structure. So they are objects, but there is not a class. There's not a specific constructor. But we still treat them just like we would an object, similar to the string objects. So they're used to store a list of elements. All the elements have to be the same type, and you can store elements of any data type, including primitive and object types. So you could have an integer or a double using number types. You can have a string. You can have an array of Boolean as another primitive type. You can also have an array of objects, so an array of rectangles or an array of bank accounts, things like that. So it's important, that's tested a lot in the free response portions, so it's important that we understand how that works in terms of storing objects inside of an array. In an array, every element receives an index. So if we have an array of n elements, and we're going to call it R, AR, each element is, it should say, numbered with a specific index going from 0 to n minus 1. Because we start counting at 0, the last index is n minus 1. Each element is accessed by using the specific notation, the name of the array, in this case ARR, and then box brackets around the index that we want to access. And this allows us to either access the data, or we can even override the data using the assignment operator. If a negative index, or an index, let's call it k, where k is greater than or equal to n, is called, then we get something called an index out of bounds exception, or array index out of bounds exception. This will cause the program to stop running, and it won't complete. So if we wanted it to have some sort of output or something like that, at that point in the program, it won't run. So this is an exception, which is a type of runtime error. So the code will compile and it will attempt to run the program, but then it'll say that the run has failed, and that this is the reason, the array index out of bounds exception. In order to initialize an array, arrays are objects, so we use the new reserved word. So the length of an array is fixed and must be declared. So when we declare it, we have to state the number of elements that are going to be in an array. So we can see the syntax here. It says data type, box brackets after it, and then the identifier is just the name of our array, assignment operator equals new, and then we state the data type again, and this time in the box brackets we state the length of the array, which is the number of elements. So for example, if we were creating an array of doubles, we could say double with those box brackets, call it data equals new double, and then 25 elements in there. So this is just an example of initializing an array. Now at this point, this array is empty. There are no elements inside of it. But because double is a primitive type, it automatically fills it all with 0.0. But it's important to note that if we wanted to then add numbers or add elements to our array, we'd have to go one by one and initialize each element. Okay, there is another way to do this using an initializer list. So an initializer list is kind of a shorter way of declaring and initializing an array. So you can see up here, right, instead of having to write this where we initialize the array, declare it with 4 elements, and then here's the initialization. Nums at 0 is 3, nums at 1 is 2, nums at 2 is 18, nums at 3 is 9. We can instead use this initializer list, which uses the notation with curly brackets, and then what we do is we just declare our array variable, and then I just state what the elements are, 3, 2, 18, and 9. So you can see the curly brackets are on the outside of the first and the last element, and each element separated by a comma and a space. So this allows us to initialize arrays. Now typically on an AP exam, in the free response portion, They're not going to ask you to declare an array. They're not going to ask you to initialize an array. Instead, they're going to give you, let's say, an unknown array, either in the form of a parameter of a method or as an instance variable in a class. And then you have to work with that array. So we're going to have to write methods that work with arrays, or we're going to have to declare them as an instance variable, initialize them in the constructor, things like that. Those are really common problem types, and we're going to look at those in a little bit. Now, importantly, the length instance variable. So each array has one instance variable, which is the length that stores the number of elements in the array. So for an array, we'll again call it ARR. To call on the length, we use this specific notation, ARR.length. Length is not a method, so it's not followed by parentheses. This is different than the string class. In the string class, the length is a method, so we use parentheses with it. Okay, so this is different. In an array, we use length with no parentheses because it's an instance variable. Now, because arrays are data structures, there is not an array class, so we can't call methods directly on an array. Instead, arrays are used as variables either in a program, they could be parameters of a method, or they could be used as instance variables inside of a class. So, here's the first one, arrays as variables. So this would be a problem where they're just asking you to traverse an array or to look at specific array algorithms. This is a lot more common on the multiple choice portion of the AP exam, so I wouldn't anticipate us having to do these types of things on the free response. Instead, on the free response, what we're more likely to see is arrays as parameters. So it says we can use arrays in methods to either manipulate the array or to somehow use the data that's stored inside of the array. Now they have to be declared as static because they're not acting on an object, right? We can't call the method on the array, so they're static, and instead the array is stored as a parameter. So here's an example here. We have an array of integers, right? And we can see the declaration public static void add 5. And what this method does is just accesses every element inside of the array and adds 5 to it. So our for loop for int I equal to 0, I less than nums.length, I plus plus. I wanted to include this in here so we can see traversing the array. We know I starts at 0 because we want our index to start at 0, and I is less than nums.length. So it's going to go all the way up to the last element, and we know that nums.length is actually not the last index. The last index is nums.length minus 1. So it goes all the way up to the last element without going out of bounds. And all I do is I just take that specific element, nums at whatever index, and I'm going to add 5 to it. So this method would just add 5 to every element. Okay, just a simple example. All right, another one, this time we have a return type, right? Public static string. So we have a return type of a string here, which means I need to return some data to the user. And the method's called first letter. Again, it takes in an array, this time an array of string objects, and it's called words. So first I declare a local variable called result, which is the empty string. And now I'm using a for each loop. So as a reminder, a for each loop goes into my array, right, words, and it takes the first element and it stores it inside of this local variable word. Okay, and then it would, once it completes the first iteration, it would then go to the second element inside of the words array, and it would store that in the local variable word. So each time, each iteration of the loop, it just stores one element from the array. So as a reminder, this for each loop can't be used to modify the array in any way, but I can use it just to access the data. So in this case, what I'm doing is I'm taking my local variable result, and I'm concatenating just the first letter of each element. So what happens at the end, result is just going to store the first letter from every element in words. And I return that result to the user. That satisfies my return type here. It's a string return type. So I'm returning a string that just contains all the first letters from every element in words. Okay, so these are really common, having to write these types of methods that act on arrays in some way. All right, and the last one, what we see really often in the FRQ section of the AP exam are arrays as instance variables. This is known as aggregation, and what it does is it a lot of times, well, it's only aggregation if we're using objects, right? If it's a primitive type, it's not really known as aggregation, and instead it's just storing a list of elements inside of a class. But a lot of times on the AP exam, what they'll do is they'll have you store a list of elements that are object types. So here's an example. We have a class called classroom, and we have two instance variables declared. One of them is private int num students. So this is just storing the number of students inside of the classroom. And then here I have private student, and we notice it's an array of student objects called roster. So now this is something that's quite unique, right? We have an object, or I should say a class called classroom, and I'm going to construct a classroom object, and inside of the classroom object I have an array of student objects. So I have an array of objects stored inside of a larger object, right? You can think of it like a bookshelf, right? A bookshelf is one object, right? It's a bookshelf, but on that bookshelf there are several book objects, right? So all those books are being stored inside of one bookshelf. This is a very similar concept. We have one object, but inside of that object there are several other objects. So it's known as aggregation. A lot of times the College Board will put this on an AP exam because it's difficult. The syntax is difficult because you have to access the elements inside of the array and then use the methods on the elements rather than calling the method on the actual variable. Right, so we wouldn't call any methods on roster. Instead, we would access the student inside of roster and then use the methods. So a lot of times on these, they'll give you the student class with all of its methods declared, and then they'll ask you to implement the classroom class, which constructs an array of student objects. Right, so these are just kind of examples, not necessarily specific examples, but more just archetypes, right? The different types of problems that you're going to see. Right, so on your homework, okay, for your assignment, I've already posted an array reviews homework through College Board, through the AP Classroom. Those are all multiple choice questions. So I wanted to focus now on the free response. So in addition to that, I'm going to post some free response questions that are actually questions from an actual AP exam. So we're going to see questions that were on previous AP exams to help us review for the AP exam this year. Alright, so you can look on Google Classroom. I'll be posting that assignment on there. If you have any questions, Tuesday and Thursday at 9:30 a.m. I have open office hours. You can come and ask any questions about the AP exam, about these concepts, about the homework assignments, anything that you want to go over. I'm willing to go over during those times. Alright, so hopefully I'll see you guys then. Have a good day.